Welcome to this explainer. Every single time you ask an AI a question, generate an image, or even just stream your favorite show, you're tapping into a global power grid that is currently being pushed to its absolute physical limits. Today, we're unpacking what we call the power paradox. It's all about how the massive energy demands of the digital revolution are fundamentally rewiring our world. We're at this fascinating crossroads right now where cutting-edge software is colliding head-on with the hard physical reality of our energy infrastructure. To kick things off, let's solve a quick riddle. What do artificial intelligence, the country of Japan, and the holy grail of nuclear physics all have in common? Now, I know it sounds like the setup to a strange joke, but I promise you it's actually the defining energy story of our decade. The answer revolves around this massive, almost incomprehensible number, 1,000 terawatt hours. To put that into perspective, just 1 terawatt hour can power a medium-sized city for an entire year. So keep this colossal number in the back of your mind as we go, because it's the absolute key to understanding a monumental shift happening in the world right now. Section 1. The global power surge. Looking at the data here from the International Energy Agency, or IEA, global power demand is accelerating incredibly fast. In 2023, the world's demand for electricity grew at a pretty moderate 2.2%. But as the world increasingly plugs in, we're buying millions of electric vehicles, installing heat pumps, and electrifying all these industrial processes, we're actually projected to jump to a 3.4% annual growth rate from 2024 through 2026. This isn't just a blip, right? It's a massive acceleration in how much energy human civilization requires just to function on a daily basis. To really wrap our heads around that global growth, just consider the sheer scale of China's expected demand increase. Over the next few years, China alone is expected to add about 1,400 terawatt hours of demand to the global grid. That single increase is equivalent to more than half of the European Union's entire annual electricity consumption. It's a staggering surge, and it's driven heavily by their rapid production of solar panels, EVs, and the intense processing of raw materials needed for all this green tech. Section 2. The AI energy appetite. Okay, coming back to that massive 1,000 terawatt-hour stat from earlier. By 2026, global data centers are projected to consume exactly that much electricity. To give you a real sense of scale here, our data centers will soon be consuming as much power as the entire nation of Japan. Think about that for a second. This isn't a gradual increase. It's an entirely new, incredibly hungry entity plugging right into our global grid. So what exactly is eating up all this digital power? Well, it's basically a trifecta. The explosion of AI, complex cryptocurrency mining, and the rapidly expanding physical data centers required to house all of this tech. AI in particular requires massive energy-dense computing power. Generating just a single image or processing a complex AI prompt requires significantly more computing effort than your standard internet search. Plus, all those servers run incredibly hot, which means massive amounts of electricity are going purely toward running industrial cooling systems. The IEA notes that these facilities demand vast, uninterrupted, 24/7 power, which presents a major hurdle for our global net zero emissions goals. Section 3. A clean energy milestone. But there is some incredibly good news on the horizon. The fascinating, highly optimistic finding from the IEA is that clean electricity supply, which includes both renewables and nuclear, is forecast to meet all of the world's additional demand growth through 2026. Let that sink in. Despite this massive surge from AI, crypto, and developing economies, low-emission sources are stepping up to carry the entirety of that new weight. We are essentially expanding the grid's capacity using exclusively clean energy. We are literally watching a monumental changing of the guard here. By early 2025, renewables, led by ever-cheaper solar, along with massive wind and hydro projects, are finally poised to unseat coal as the dominant global power source. And as a direct result of that, global coal-fired generation is entering a slow, structural decline. We're witnessing a historic pivot play out in real time in how humanity generates its base power. You'll definitely want to mark your calendars for 2025. Because next year isn't just a massive milestone for renewables overtaking coal, it's also the exact year global nuclear power generation is set to hit an all-time record high. It's expected to exceed its previous 2021 record as global maintenance cycles finish up, older plants restart safely, and cutting-edge new reactors finally come online around the world. Section 4. Big Tech Goes Nuclear. Here's the thing. Intermittent solar and wind just aren't always enough for 24/7 data centers that literally cannot afford to go offline. Because of that, big tech is looking at two sci-fi sounding next-generation technologies. First up, small modular reactors, or SMRs. Think of these as simplified, shrink-wrapped, passively safe nuclear reactors that can be built incredibly fast in a factory setting rather than on-site. The second is fusion, the literal holy grail of energy. It's the zero-carbon process that powers the sun and stars, promising nearly limitless energy without the long-lived radioactive waste associated with traditional nuclear plants. Now, rival tech titans are placing some unprecedented, massive financial bets to secure their energy futures. Microsoft just signed the world's first fusion energy purchase agreement with a company called Helion, targeting 50 megawatts of power to be online by 2028. Meanwhile, Google has signed the world's first corporate agreement for SMR nuclear energy with Kairos Power, aiming to bring a massive 500 megawatts online by 2030. These tech companies are no longer just buying energy, they are actively funding the next leap in physics. Let's peek under the hood of Google's partner, Kairos Power, for a second. Instead of using highly pressurized water like traditional plants, they use a molten salt cooling system, combined with a robust ceramic pebble-type fuel. What this means for the grid is that the reactor can operate at low pressure, enabling a simpler, much more affordable, and passively safe nuclear design. Basically, if something goes wrong, physics itself cools the reactor down without needing human intervention or external power. It's a real game changer. Meanwhile, Microsoft is being equally aggressive on the fusion front. Brad Smith, Microsoft's vice chair and president, recently highlighted their deep optimism that fusion energy can be the crucial technology to help the world transition to clean energy. And Microsoft isn't doing this just to power their AI tools. They're using the specific agreement to help achieve their incredibly ambitious corporate goal of becoming entirely carbon negative by 2030. Section 5. The Future Grid. When you put all these pieces together on a timeline, it's clear we're in a thrilling race. Next year, in 2025, renewables overtake coal and nuclear hits a record high. Just 1 year later, in 2026, global data center energy usage doubles to match the entirety of Japan. Fast forward to 2028, and Helion targets bringing the first commercial fusion plant online from Microsoft. And by 2030, Kairos deploys its first SMR for Google. We are watching massive, terrifying energy demands accelerate right alongside unprecedented, world-changing, clean energy innovations. I want to leave you with this provocative thought to ponder. We started by looking at the staggering strain that AI and data centers are putting on our global electricity grid. But when you look at the billions these tech giants are now pouring into advanced nuclear and fusion, will the AI revolution, the very technology threatening to overwhelm our power grid, be the financial catalyst that finally cleans it up? It's a fascinating paradox. Thank you.